So welcome everybody to this latest video on 162 Maths, and in this video we'll be focusing on similarity, taking the knowledge of similar shapes onto similar area and volume. So if we take a square with side 1 cm and we enlarge it by a scale factor of 2, the enlarged shape will now have a side length of 2 cm. Now although the length has been enlarged by a scale factor of 2, what about its area? And this is what we're going to investigate now. So in terms of this, we can see that this square has a length of 1 cm, and that would also be 1 cm. So this square has an area of 1 cm squared. Now if we enlarge this by a scale factor of 2, which is what we've done, so scale factor of 2, then the length will now times that by 2, we get 2 cm. That's going to be 2 cm. So the area of this square is now 4 centimeters squared. Now you can see how that although the length scale factor has been doubled, that the area has actually been more than that. It's more than double. So it's actually quadrupled. So it's times 2 times 2. So let's have a look at another example of this. So this time let's use different numbers. So let's go for 3 centimeters, and let's say we're going to enlarge it by a scale factor of 4. So for this here we've got 3 centimeters. This therefore is going to be 3 times 4, which is 12, and that's also going to be 12. Now here with this square we've got an area of 9 centimeters squared. However, for this enlarged square, that's going to have an area of 144 centimeters squared. So you can see how even though the length has doubled, let's say quadrupled, that the area hasn't quadrupled. It is different. It's actually more than that, because obviously 9 times 4 is 36, and obviously the area of this new enlarged shape is more than 36, so we can't apply the same number as such. So now let's have a look at volume then. So this time let's start off quite basic, and let's say we've got a 1 centimeter by 1 centimeter by 1 centimeter cube. So looking at this, so we've got a length of 1 centimeter. Now if we look at the cross-sectional area, so let's just look at the area of this blue side here, then that's going to have an area of 1 centimeter squared. And if we look at the volume of this, then that's going to be a volume of 1 centimeter cubed. Now let's say we're going to enlarge this shape by a scale factor of 2. So here we've now got a length of 2 centimeters by 2 centimeters by 2 centimeters, because all the lengths will be enlarged by 2, because that's the scale factor. So here we've got a length of 2 centimeters. The area, or the cross-sectional area, this is going to be 2 times 2, which is 4 centimeters squared, and then the volume is going to be 2 times 2 times 2, which is going to be 8 centimeter cubed. So you can see here that although that the length scale factor has been doubled, that the area hasn't doubled and the volume hasn't doubled. So let's just have a look at another example. So let's say that this cube has got lengths of 2 centimeters, 2 centimeters and 2 centimeters. And let's say we're going to enlarge this shape by a scale factor of 3. So from here we've got our length as being 2 centimeters, and on this enlarged shape the length is therefore going to be 6 centimeters. So we just quickly label that. Now it doesn't really apply to cubes, cuboids or any other particular 3D shape. This applies to everything. So this connection that we're trying to make it's not really just applicable to cubes. It's to do with all types of areas and all types of volume. The only reason why I've chosen cubes is to try and make it easier for you to understand and be able to do this without using any particular formula. So if we then look at the area, so the area of that square is going to be 2 times 2, which is 4 centimeters squared, and the area for this is going to be 6 times 6, which is 36 centimeter squared. And if we look at the volume, then that's going to be 2 times 2 times 2, which is 8 centimeter cubed, and the volume of this particular cube is going to be 6 times 6 times 6, which is 216 centimeter cubed. And again, just to reiterate that although the scale factor of the length is times 3, that the area has not been tripled and the volume has not been tripled. So you can see how these numbers are going to be different. Now there is a connection between all of these numbers, the area, the volume, that's all linked with the length scale factor, and that's what the main purposes of this video and what we're going to lead on to now. Now this is something definitely that's worth adding in your notes, and something that hopefully you may have spotted from the examples that we've done. Now the key notes for this is that if the length scale factor is k, then the area scale factor, which is going to be completely different, is going to be k squared. And if the length scale factor is k, then the volume scale factor is going to be k cubed. And that's definitely something that's worthy of putting in your notes. And what we're going to do is we're going to go into the previous examples to show how this is the case. So to try and find a new volume or find a new area when you're just looking at one particular scale factor. So if we go back to our cube here, so here we can see that our length scale factor is 2. So then that means that the area scale factor will therefore be 2 squared, which is 4. And the volume scale factor will be 2 cubed because the length scale factor is 2. And that will be 8. Now if we go back to these numbers here, that if I obviously multiply that by 2, 1 times 2 is 2, but if I times that by 4, which is my area scale factor, I get the answer of 4, and if I times this by 8, I get my volume. Now if we try that with different numbers, so for example we go back to this one here, so here our length scale factor is 3, so that means our area scale factor will be 3 squared, which is 9, and the volume scale factor will be the length scale factor cubed, which is 27. So going back from here, if I knew what the area was of 4 and I knew that the length scale factor was 3, then all I need to do is times that by 3 squared, or also known as 9, and 4 times 9 gives me 36. Here I multiply 8 because that's the volume. If I know the new volume, then I look at the length scale factor, which is 3 cubed, and which is 27. So if I multiply that by 27, 8 times 27 is 216. And you might find this a much easier way of working with length and scale factors of similar shapes when they're being enlarged. So let's have a look at some example questions now. In this it says in each question the shapes are similar, which is really important because obviously none of this works if we don't know that the shapes are similar. And it says work out the area A or the length L. Now it's really important you know what it is you're actually wanting to find. So the mystery letter or the missing letter will either represent length, area or volume, and that has a massive effect on how you'd actually go on to work this out. Now with question 1, which I'll just split doing this. Now whenever you're starting these questions, I would always recommend that the first thing you want to do is your main aim is to try and find what the length scale factor is. Now in some cases that might be really obvious, you can then go from there. But again, that should be your first aim of what to work out. So the first thing I'm going to do here now, looking at these two shapes, I can actually work out the length scale factor by doing these two. So it's going to be 9 over 3. So the length scale factor is going to be 3. Now A in this question is the area. So if the length scale factor is 3, then the area scale factor is going to be 3 squared, which is 9. Now from this I can now multiply the 4, and I'm multiplying because I'm going from smaller to bigger. And again, if you've got no idea what I'm talking about, then I do recommend you watch the previous video looking at similar shapes and similar triangles. So here A equals 4 times 9, because 9 is an area scale factor and it's the area that I'm wanting, and that gives me 36, and it'll be centimetre squared, and there is my final answer. Looking at question 2, again, the first thing I do is try and find the length scale factor. So here I've got the length scale factor is 8 over 2, which is 4. So therefore, that the area scale factor, obviously it's the area that I'm looking for, is going to be 16. So obviously it's 4 squared. So then from this, I can then work out what the A is going to be. Now, A is on the smaller shape, so to work out A here, I take the area of the big shape, and this time I'm going to divide it by the area scale factor. And if I work out what 144 is divided by 16, that gives me an answer of 9. So it's going to be 9 centimeters squared. Now for question 3, so here what I'm doing here is I'm trying to find a length. Now in the two similar shapes I've been given the volume, the area. So here the area scale factor is going to be 18 over 8, which is going to be 18 divided by 8, which is 2.25. Now that means that the length scale factor, well, if this is k squared, and I will know what k is, then what I need to do then is to square root 2.25. Now if I square root 2.25, I get an answer of 3 over 2, or 1.5. Now this is what I'm wanting because obviously I'm trying to find a length. So from this I can then say that L is going to be 15, and I'm going from big to small, so I'm going to divide by the scale factor, which is 1.5, and that gives me a length then of 10 centimeters. And again, just centimeters because I'm working with length, and there is my final answer. So now let's have a look at these next 3 questions. So again, looking at question 1. So for this, V is the volume. So the first thing I want to do is try and find the volume scale factor. So how am I going to do that? Well, first things first, I'm going to look at what 2 sides do I know. So do I know 2 lengths? Do I know 2 areas? Do I know 2 volumes? Well, here I've got 2 lengths. So the length scale factor is therefore going to be 4 over 2, which is 2. Now because I'm looking at volume, that means then the volume scale factor, because obviously I need the volume scale factor to work out what V is going to be 2 cubed, which is 8. Now looking at this and using the 6 centimeters, now I'm going from small to big, so I need to multiply, so that means V equals, it's going to be 6, which is the volume of the smaller shape, multiplied because I'm going from small to big, times 8, which gives me an answer of 48, and the units are going to be cubed, so there is my final answer. Now looking at question 2, again I'm given 2 lengths, so again, and V is the volume, so I've got the length scale factor is going to be 30 divided by 7.5. So 30 divided by 7.5 is 4. So that means that the volume scale factor, because obviously I need the volume scale factor, is going to be 4 cubed, which is 64. So now here, to work out V, I use the volume of the shape that I know, which is 192. Now because I'm going from big to small, I need to divide by the volume scale factor, which is 64. And so that's going to be 192 divided by 64, which gives me an answer of 3. So it's 3 centimeter cubed. Now moving on to the cones. So again here, I need to work out what L is. Now the information I've been given is I know the volume of these 2 shapes. So the volume scale factor is going to be 270 over 80. Now if I work that out on my calculator, 270 divided by 80, it gives me 27 over 8. Now I'm going to keep it as a fraction, so I would recommend that you do keep it as a fraction, otherwise you'd be working with a decimal. So I would say, as a tip, leave as a fraction. Now this 27 over 8 resembles what k cubed is. Now I want to work out what the length scale factor is, so I need to work out what k is. Now to go from k cubed to k, what I need to do is cube root. So therefore, the length scale factor is going to be the cube root of 27 over 8. Now if this is a non-calculator paper, then the cube root of 27 is 3, and the cube root of 8, which is 2. And if you wrote it as a decimal, it would be really difficult for you to do without a calculator, but there is my length scale factor. Now with this length scale factor, I can then work out what L is. So here I'm going to go 3. Now from this, you just got to decide am I going from big to small or small to big? Well, I'm going from small to big. So I'm going to multiply that by the scale factor, which then gives me 9 over 2, or 4.5 centimeters. And there is my final answer. Now the key concept is just realizing what it is you're actually working with and what it is you're actually trying to find. So if you're trying to find a length, it's always important that you then label it as K and then either use the two volumes or the two areas to then work out what the length scale factor is. So whatever you are working out, that scale factor is what you need, and you'll need to manipulate the information that's given to you in the question to therefore work that out. So now let's have a look at some more exam style questions. So in this particular question it says that two similar solids A and B are shown. Solid A has a volume of 60 centimeter cubed, and the first question is asking us to work out the volume of B. So with question A, what we need to do is we need to work out what the volume scale factor is. So here we're going to know that the length scale factor is 6/3, that's 2, so that means that the volume scale factor is going to be 2 cubed, which is 8. Now going from here, we're going from big to small, so here the volume of B, well actually we're going from A to B, which is a common mistake that people can make. So we've been given the volume of A, so the volume of this, if I just write V equals 60, I want to work out what the volume of B is. The volume of B is going to be the volume of A, which is 60, multiplied by the volume scale factor, which is 8. And if I do 60 times 8, that gives me 480, and it's going to be centimetre cubed. Now it then says, for question B, it says solid B has a surface area of 140. So this surface area, if I just poorly colour, so just this pink base, and yeah, has got a surface area of 140, and what we need to do is we need to work out what this area here is going to be. So looking at this, what we then need to do is, for B, we know that the length scale factor is 2, so therefore the area scale factor is going to be 2 squared, which is 4. Now for this, we're going from big to small, so the surface area of A is going to be the surface area of B, which is 140, divided by the area scale factor, which is 4. So if I do 140 divided by 4, gives me an answer of 35, and that's going to be in centimetre squared. And there is my final answer for that one. Let's have a look at this next question then. It says that A and B are two cylinders and are mathematically similar. Now that's definitely a word that you need to look out for when dealing with this particular topic. Now it says that the area of the cross section of the cylinder of A is 18 centimetres. Work out the volume of cylinder B. Now the first thing we notice is that we're not being given the volume of A. So the first thing we need to do here is use this information and this diagram to work out that the volume of A is the cross-sectional area, which is 18, multiplied by the length, which is 5, and that gives me 90 centimetre cubed. So now from this, what we can then do, and I'm just going to leave that on the side, so now what we need to do is work out what the volume scale factor is, because I need to work out what the volume of B is. Now the length scale factor is 10 and 5, so it's going to be 10 divided by 5, which is 2. So that means that the volume scale factor is going to be 2 cubed, which is 8. Now from this, because I'm going from small to big, so that the volume of B is going to be the volume of A, which is 90, which I've worked out, multiplied by the volume scale factor, which is 8, and that gives me 720, and that's going to be centimetre cubed, and there is my final answer. Now moving on to the next question, it says that here we have two similar bottles are shown, and again that keyword of similar. It says the smaller bottle can hold 500 millilitres of water. Now here we're dealing with capacity, so capacity is very similar to volume. It's just looking at how much liquid we can fit into a bottle rather than how many cubes we can fit in, but the same thing kind of applies. And the question saying is how much water, so in other words, what this question is asking us is what is the capacity or volume, you could say, of the bigger bottle. Now the information I've been given on both these two shapes are the length. So the first thing I need to do here is work out what the length scale factor is. So the length scale factor is going to be 21 over 15, and I can simplify that as a fraction as 7 over 3. Actually, no, it's going to be 7 over 5. Just correct that. There we go. Now, as I said, always recommend leaving this as a fraction. Now, the next question is therefore that the volume scale factor is going to be 7 over 5 cubed. Now I could work that out, but I'm going to leave it as 7 over 5 all cubed. Now don't write this as 7 cubed over 5 because that is a mistake. You need to make sure that you've got 7 over 5 and it's all being cubed. So therefore the volume, or capacity I should say, so the capacity of the bigger bottle is going to be the capacity of the smaller bottle, which is 500 millilitres, multiplied by 7 over 5 cubed. Now if I type that into my calculator, so 500 multiplied by bracket 7 over 5 cubed equals, and that'll give me an answer of 1372 millilitres. Now if I wanted that answer in litres, then that would be 1.372 litres. So either of those two answers should be correct. Moving on to our next question. So it says here that we've got two similar solids, A and B are shown. Again, that keyword of similar. The solids are made from the same material. It says that the surface area of B is, and again the surface area is this here, and that's 40.32, and the surface area of A, which is this here, is 28. And the question is saying that the mass of B, so in other words the volume, is 6,912 grams, and the question is asking us to work out the mass of A. So in other words, this is like the volume, and it's been asking us to work out the volume. So looking at this, now the two bits of information, we don't know what the length scale factor is, but we do know what the area, we can work out what the area scale factor is. So the area scale factor is going to be the big one over the smaller one over 28. And if I work that out on my calculator, so 40.32 divided by 28 gives me an answer of 36 over 25. Now this is what k squared is. So that means that the length scale factor is going to be the square root of 36 over 25, which is going to be 6 over 5. And therefore the volume scale factor is going to be 6 over 5 cubes. So for this particular question, I've actually had to work out all three of those scale factors, in which I shouldn't have really highlighted that one. Get a better highlighter. So there's my area scale factor, there's my length scale factor, and this is my volume scale factor. Now again, I'm going to leave that volume scale factor as a fraction. So looking at this, I'm going from small to big. So the mass of A is going to be the mass of B, which is 6912, divided by, because I'm going from big to small, and it's going to be 6 over 5 cubed. Now it does look messy, but again this is a high level question, so 6912 divided by bracket and enter the fraction of 6 over 5, close the bracket, and then we're going to cube that, and you should get an answer of 4,000. And looking at the units, it's going to be grams, so it's 4,000 grams. And there is my final answer. Now again, the main concept of this is when you're given with similar shapes and dealing with area and volume is look at the two bits of information you've been given, work out that scale factor, and then go automatically. If it's a length scale factor, then to get the area scale factor you just need to square it, to volume you cube it. But if you're given the two areas, you need to square root it first, and that'll give you the length scale factor. Then if you need to find the length, then you can use that. If you need to find the volume, you cube that length scale factor. So this last example is like worst case scenario. So this is where I've had to, given I can work out what the area scale factor is, I then need to square root that to work out what the length scale factor is, and then cube that answer to get the volume scale factor, which is what I need. Now also another thing to bear in mind, that mass and volume, capacity, all similar things. Area, surface area, same thing, and obviously you've got the lengths, which can only be a length to go forward. Now we'll put some practice questions in the description below for you to practice everything that's covered in this video, but as I said, this is a high level topic and takes your knowledge of similar shapes and similar triangles to that next level.